Hello guys, welcome back to another recording of me speaking and helping you guys out. So I just got the marks back for the CNC test and most people did pretty good. So hopefully you guys appreciated that. Don't expect that to ever happen again for CNC. I'll be having a lot of people getting really good marks, which is good. It is, but it's okay. So I wanted to go through this class to go over CNC, the last test for CNC. It's probably going to be your harder test of the year. Unless you know what you're doing, then you'll do pretty well. So I wanted to show you, I'm going to post this example, but for you to follow, and a cheat sheet for you to follow as well. I'm just going to share my screen. Start talking. Okay. So one thing I forgot to open up was that cheat sheet that I found. Let's go find that. What did I call it? I called it Programming General Rules. So I'm going to post this one. Okay, so this goes over all the general rules that I'm going to be marking and looking for on the test. It's just a good starting point for you guys. Again, I talk about it in this paragraph, but it's not necessarily exactly what you always use. In the case for this course and this semester, this is what you will use. And we'll reference back as I'm doing the test to what I mean for everything, but obviously roughing step over, the distance between cuts, anywhere between 25 to 50% works, but I like 33 as a good number. Your depth cuts I like seeing at 100%, but if the pocket is less than the tool diameter, then we don't need depth cuts. We just cut directly to the max depth. When we're helixing in, doing our pocketing or circumilling operations, I do like seeing helixes, and normally the values you can input for that to make a good helix is 10% and 45%. But just know if your helix doesn't show up, it just means that helix is too big for the pocket. So just to fix that, you normally just take down that maximum helix radius. Again, you guys won't see that as a problem, but going into next semester is just a good note to have. When you are helixing in, I like to see a 1 to 5% angle, and 3% is a good number. But again, it changes depending on what diameter tool you're really using and kind of just by your eye. But again, anywhere between 1 to 5% is good, and I would just use 3 as a good starting point. When you're breaking through the part, I like to see 0.01 or 10th thou as a breakthrough. And when you're doing contours, I like to see a 10th thou overlap. When you spot drill should be 50 thousandths of an inch, it definitely does depend on the size of the hole, but normally 50 thou works pretty well. There should be no tip comp when you're spot drilling. When you're peck drilling, your peck should be 100% of your tool diameter. When you're tap drilling, this might help you guys for your assignment, but whenever this is only like these two things. Is going to be like this one thing where it says add 50 thou to the depth of your tap. So if the reason why we do this, and maybe I'll do a quick lesson on this. So when you're drilling through a part, it doesn't matter. I haven't taught you guys this yet because every time we've done a tapped hole, it's been through a part. But what happens when the tapped hole is in the part? It's a blind hole, right? So what's going to happen is if you have your hole. So if you go and drill that hole to this depth, and then you come in and you use your tap to the same depth, odds are it's going to break. It's simple as that. If you go to the same depth, when the tap reaches the bottom, it's going to bottom out of the hole, and then that tap is going to snap. So whenever you're doing blind holes, if I say to do tap to 1 inch deep, right? Then what I want to see, and actually this will be on the test, so if you don't understand this, please reach out to me. So if your tap depth is 1 inch, right, meaning that we want 1 inch of thread, we're going to add on, remember that so our drill, instead of going down to 1 inch like we would here, it's actually going to go just a bit further, like this. So I said add 50 thou. So your drill depth in this case would be 1.05 but you have to make sure to add your tip comp. And then there's no breakthrough because it's a blind hole, right? So now the distance between here and here is 1.05, and that allows us, when we come with the tap, right? And then our tap depth, if we're just doing an inch, we could just say equals -1 in this case, and that should be negative up there too. And that means that the tap is going to come down to here, which give that extra 50 thou that we drilled just gives us a little bit of a space. So and normally companies are okay with you drilling the drill a little bit deeper in order to get 1 inches full of tap. And then when you're tapping, also make sure that your tip comp is on as well. And adding that 50 thou will make sure that that tap does not bottom out to the bottom of the hole and break in there. If you don't consider that, that will happen. So that's a great note. If you don't fully understand it, then just please reach out to me, and I'll definitely explain that to you again. Maybe we can go one-on-one. And then, like I said, your tap depth is just the depth called out on your drawing, like -1. But make sure you have tip comp, and then obviously that's an absolute value to Z0. So when we do this, right, if we have a pocket, right? So this is another thing, guys. So if we have a pocket, this distance between here and here is 0.25, and then you have a hole on your part, and that's called out to be 1 inch deep, right? When you go and you do your parameters for tapping, the depth is not 1 inch, because it's 1 inch from here down. But everything that we give is relative to our Z0. So from Z0, that is 1 plus 0.25. So actually the depth in that case would be 1.25, okay? And again, please let me know as soon as possible if anything does not make sense completely to you. And then when you countersink, you can calculate that based on the diameter from your drawing. Make sure there's no tip comp on there. And just like we've done before with, or you've learned that with Ted about how to calculate the countersink depth, right? So we'll do all that today. And then when you're chamfering in 2D with a sketch, your top of your stock is just going to be the value of the top of your chamfer. And then your depth is going to be the top of your stock, okay? Again, that's just to make it easier for you. I don't know if you tried chamfering before, but that means that your top of stock is going to be 0 and your depth is going to be 0 if the chamfer is at the top of the part. I'm not really going to explain why, but it just works out that way. So if your top, like if you're doing this chamfer and this is your Z0 right here, the top of your stock for this chamfer is Z0. But if you're doing a pocket inside of here, and again, this distance is 0.25 from here to here, then your top of your stock is -0.25, and then your depth is just equal to your top of your stock as well, minus 0.25. And again, we can go through that and take a look on how that's supposed to run, okay? So I'm going to post this later on. I'll post this, and then I'll post the practice test. It's literally just one of the tests I've given my classes before, so yours is going to look exactly the same. It should look familiar to what you did with Ted, maybe a little bit different with the square pocket maybe, but this is exactly what it looks like. So using MasterCAM, it's not going to be on Splash Top, okay? That's not going to happen. You guys are all going to be using college computers. You're going to be producing a CNC program for your supplied part drawing using all required tool paths that are required to make the part. You're going to calculate all speeds and feeds, and yes, I did tell you guys that I wouldn't make you do that, but I've thought of it, and yes, I believe you guys should be able to do speed and feeds. So you're going to calculate all your speeds and feeds according to below. Once you're finished, you're going to save your program as a certain format. Again, I just like that. It's an easy thing for me to watch it, and then you're going to hand it in on Blackboard. You won't hand it into OneDrive. You'll hand it to Blackboard. That's much better. Or you can just hand it into my drive. I can make a handed folder. So you're going to have 2 hours. So if you start at 4:30, you're going to have until 6:30. But we're going to start at 8:30. So you'll have till 10:30 to hand in your test. I'm not going to let you guys go late. The second it hits 10 p.m., I could lock you guys out of your computers, and that'll be it. If I don't have your test, I'm just not going to accept it. And if you have any questions, you can raise your hand. Again, read all that information, okay? I'm going to give you the stock size, easy. I give you the stock size, I give you the cutting speed, and I give you a chip load per tooth. I might make it so that there's 2 chip load per tooth depending on the diameter tool you're working with. I might just change that up. Number of flutes, if you have a face mill, 6. Any other tool has 2 flutes. And I said for the square pocket, use the largest tool diameter possible. And I don't know what Ted really taught you guys. But when you're doing an inside square on a workpiece, you're limited to the size of tool you can use. Whereas the outside of a part, who cares? You can use whatever tool you want. That's because when we go to cut a square pocket, right? Square pockets have to have internal corners because an end mill is round, so it's going to leave a round cut. Can't get a straight cut like that. There's no way, right? So if I give you this drawing and I call it a radius of 0.25, I told you to use the largest tool diameter possible. And this is just me testing you on whether or not you know what max tool diameter you can use. The instance when you're doing a square pocket, the max tool diameter you can use is simply equal to 2 times the radius, right? So if the radius is 0.25, right, which is the distance between here and here, you can double that to figure out the diameter of the cutter. So in this case, if the radius is 0.25, you're going to use a 1/2 inch cutter in that case. If I say radius 0.375, you're going to use a 3/4 inch cutter. And that's the only time I'll tell you exactly what tool to use. Other than that, you're able to use whatever tool you want. But I would recommend you just kind of stick with the tools that I use in my program. Normally I do a 1/2 inch end mill, 2 inch face mill, 1/4 inch or 3/8 spot drill. Obviously the drills and the taps have to change depending on the threads, right? So you guys are going to be required to actually look up your threads. And again, this is going to take practice, guys. This isn't easy. And I know it's busy, but you guys, this is the test. This is a hard test. If you don't study, you're not going to do well. I'm telling you that right now. And there's not going to be a chance for a retest. There's no way that's happening. So your mark you get is the mark you get. If you do bad, you do bad. If you study a lot and you do good, that's awesome. So we can look at this and we can see that there's a chamfer below on this hole. There's going to be one chamfer. And again, I double thought it, and actually the chamfer is not going to be bonus. It's just going to be part of the test. I'm going to teach you how to do it. That's why. Okay? You guys have learned how to do a chamfer before, so it's fair. I've thought it through. It's fair. You guys all got pretty good marks going into the test too. So I also just give you the hole positions so you don't have to calculate anything. You're not going to be doing any heavy math. I give you simple dimensions, all nice for you to just quickly make it. So that being said, let's do this, okay? Let's make this part. So I'm going to go to my MasterCam. So the first thing I'm going to look at is I have a 3.4 by 3.4. Again, you got to be fast when it comes to the wireframe, right? First thing I'm going to do is go to configuration and go and set up in inches. You should have that ready to go before the test is even here. But I'm going to go wireframe, rectangle. Okay, I'm going to anchor to center, and I'm going to click center, and my width is 3.4 and my height is 3.4, right? Enter. Okay, then I'm just going to fit this to my screen. Okay. And then it's going to be an inside square 2.75 by 2.75. Okay, so same thing, another square, 2 points. I should make my center first. 2.75, tab, 2.75, enter. Okay, then we have a circle. Oh, my bad. Circle that's diameter 1.5 inches. And I can't express this enough about how close the test will be to this. Everything will be a little different, like the holes will be different, the shape, it might not be a perfect square, it might be a rectangle, the holes might be in a different layout, but in the essence, it's all the same, okay? And then I have 4 holes, right? So I'm gonna go back, and my holes are coordinates 0.75, x each way, 0.75 each way. So I'm just gonna make 4 points. Again, points, I'm just going to say 0.7 or 0.75, 0.75, 0.75, comma, negative 0.75, enter, negative 0.75, 0.75, enter, and then negative 0.75, comma, negative 0.75, enter, perfect. Then I'm going to reference back to my drawing. I have a 1/4 inch chamfer going all the way on the outside, so I'm just going to hit chamfer entities. I'm just going to say chamfer chains. You can select the outside chain. I don't know if you guys have ever learned that, but set your distance, which is 0.25, bam, done. Okay. Then we'll go back, and my internal radius is 0.1875. So fillet entities, same thing. I could select the chain. It's a lot faster, and my radius is going to be 0.1875. And okay. There we go. There's my part. Again, that took me no time at all. You guys should be able to do that pretty fast, or else you won't fare too well on the on the test. I mean, you're not going to be as fast as me, but you should still be pretty fast. I'm just going to select default mill. You guys can select whatever machine you want. Just do default mill just to be easy if you want. I'm going to go first thing I do before I forget. You get marked on this. I'm going to change this to Greg Test or something like that. And then tool settings, again, random number. And then check off all these boxes, the easiest few mark you'll ever get. Then we're going to my stock. I need to figure out what my stock is. My stock is 3.5 by 3.5 by 2 inches, as you see right here. Again, even the way the test looks is going to be the exact same. You're going to see all the same spots where your stock is, so you'll know exactly where to look for your information. And my Z height is 2 inches. Okay? Okay. It didn't work, so I'm just going to hit select all entities, and then it was, sorry, 3.5 by 3.5. Sometimes hitting all entities I need to do to make it work for some reason, and then there we go. Get my part now. It was, yeah, there we go. Perfect, exactly what I want, okay? And close that down. I also like organized stuff. I don't like seeing a messy program. I like seeing a nice and neat program. The only thing, though, is that we should be leaving we have to move our stock up 0.1 because we're facing it, right? So we're going to move our stock up. We're going to go back to our stock settings, and we're just going to raise it up 0.1 in the Z, or actually just do 0.01. Actually, just 10 thou is fine. Raise it up that 10 thou just so we have that little material on the top to machine off. I don't know. Maybe I said that on the test. I didn't. Oh, the part, sorry, the part is 1.75 inches. So we're actually adding 0.25 inches to the top of the part. My bad. .25 inches. Okay. First thing we're going to do is face off that extra stock, right? Every program should start with facing if it needs it. So I'm just going to go face. You don't need to select anything. Go to your tool. Again, I like to use a 2-inch face mill, so I would recommend that you guys just do what I do because I'm going to be marking it, right? 2-inch face mill, okay? So 2 inches. The cutting speed in this test is 450. So 450 times 4, right? Divided by 2, I get 900 spindle speed, which sounds about right. 900 times 6 times 0.004 gives me 21.6 inches per minute. And then my my plunge rate, again, this is either going to be, so your plunge rate is equal to your feed rate, or it's half of your feed rate. If when the cutter's coming down, it's not cutting material, your plunge rate should be equal to your feed rate. In this case, the face mill's coming down outside the part and then feeding. So our plunge rate should equal our feed rate. And yes, you will be marked on that. And then I want to see rapid retracts checked off as well, because that means once it's done cutting to wrap it out. If it doesn't wrap it out, it will take forever. It'll go, you don't want that. So it's always rapid retract, okay? For the other operations, you'll see that my plunge rate is actually going to be half of my feed rate because it's cutting as it's plunging, right? Now, as Ted probably taught you, zigzag and then high-speed loops, and we're going to leave 0 stock on the floor, okay? We don't need to touch that stuff. We'll see what it looks like, but it should be fine. You're face milling, even though you're cutting off a 1/4 inch, you don't have to do depth cuts. Just leave it at 1 cut. As always, clearance 1, retract 0.1, absolute, feed plane 0.1, top of stock is 0. No, top of stock, sorry, 0.25, and our depth is 0, right? Because we have 0.25 inches above. We're going to turn coolant on. Just turn on flood or mist, whichever one. I like flood, and that looks good. That looks like what I want it to do, right? So I'm just going to go to the next one, and I'm going to close down that folder. I love when people hand me a test and all the folders are nicely closed. It just makes it really nice and neat looking for me, okay? Next thing I want to do, I'll probably do the outside contours. Let's just add a contour toolpath. Let's just select the outside. I like to make my arrow just face the correct way. As for climb milling, I believe there's actually an option in here to do that. I think, maybe not. Yeah, you want to make sure for contours that you're, 1 second. No, it doesn't give us an option for cut or conventional or climb. So you want to make sure that your arrow is pointing the right way for climb milling. Another thing you'll get marked on. Again, nothing to leave on the walls. No depth cuts. Yeah, your depth cut. I'm going to use a 1/2 inch end mill, so our depth cuts are going to be 1/2 inch. I forgot to select that. So let's filter for an end mill. And let's go find a 1/2 inch end mill. I like 1/2 inch end mills a lot. You guys saw it on the machine. They work really well. I'm going to take my cutting speed, which was in this case, again, 450 times 4 divided by 0.5. I get 3,600. That's probably pretty conservative for a 1/2 inch end mill, but that's fine. 3,600, and then I'm going to times 3,600 times 2, because I said 2 flutes, times 0.002. I get 14.4. Pretty conservative. You guys will have different numbers. I've come up with a better way of teaching my speeds and feeds. Again, when it's plunging, it's not cutting into metal. It plunges to the side and then curls in, right? So my feed rate should equal my plunge rate, and my rapid retract should be on. Okay. Now my depth cut, 0.5. Yes, that's what I want. I don't need any fishing passes. Lead in, lead out. As I said on this thing, my overlap should be 0.01 for contours. I'm going to turn on a 0.01 overlap for that contour, and 100% is fine for all those, so we'll leave that. We are cutting through the bottom of the part, so I am going to turn on a breakthrough, and normally my breakthrough is going to be 0.01, kind of like what I said right here. Breakthrough 0.01 if applicable. You only add a breakthrough if you're breaking through the bottom of the part. Your clearance is 1 inch. Always check that box off. 0.1, 0.1. The top of stock is now 0, and your depth is minus 1.75 because that's how deep the part is. Bam, there we go. And again, you see it's breaking through just a tiny little bit. Okay, nice. I like it. So let's just start from the beginning and watch this all play out. For some reason, every time in MasterCam, it always doesn't work the first time. I don't know why. Let's just watch it, and we can restart it. Everything looks really good. I don't notice anything weird, no stock on my walls. Everything looks like it's cutting perfectly. Good job. Okay, let's do these next pockets, and the way you want to do it is probably cut the first the shorter pocket first, and then the pocket that goes all the way through. Okay, so let's do that. Let's cut this pocket. So we're gonna do. I want to see you guys using 2 different operations, okay? I want to see you use your pocket milling for the square pocket and then the circle milling for the circular pocket. And this internal pocket, this one could be a square or this one could be a circle. It might change, right? But no matter what, I want to see you use a pocket and a circle mill. So this one we'll call it the pocket. We'll grab that and we'll hit OK. We'll go into our tool, and what is our tool going to be, right? Our tool needs to be, it depends because we have a radius on the internal corner. So this radius is 0.1875. So if I take 0.1875 and I times it by 2, I get 0.375. So I'm going to use a 0.375 tool because I said for the square pocket, use the largest tool diameter possible. Because I could get away with a smaller tool. I could use a 1/4 inch or 0.125, but I can't use a 0.5 inch. It won't work, right? Maybe let's try it with a 1/2 inch. Let's see what happens. I'll go back to the speeds and feeds later. But let's leave 0 on the stock and walls. Roughing, again, step over, I liked it 33% for step over. It automatically calculates that out. Again, anywhere between 25 to 50 is acceptable. And then I want to see you guys use a nice pattern. I don't want to see, I like when it starts in the center and it moves outwards. So something like a parallel spiral or a high speed or a true spiral is really good. I actually don't really like the true spiral because it makes interrupted cuts. I won't get into that now. So just something like a parallel spiral would be perfect. I don't like the zigzag look. It should start inside and move outwards. So that's my preference. Your entry motion, again, I even said this, your minimum tool path is, or your maximum's 45 and your minimum's 10. Those are 2 good numbers to use. It doesn't have to be that, but those normally work out pretty well. Okay, and our plunge angle I like 3 degrees. Again, on this, I say 1 to 5%, but 3 is normally a good number. Okay. Finishing, we don't need to do finishing passes. That's going above and beyond. If you have time for that. We don't have a lead in, lead out. No, we'll just leave it off for now. Linking parameters 1 inch, 0.1, 0.1. Top of stock is 0, and our depth, I don't know. Let's check it out. How deep is this pocket? This pocket is 0.125 inches deep. So I'm going to say minus 0.125. Okay, and coolant on as always. Hit go. That looks okay. I don't really like how it starts there. It should start at XYZ or XY0, but I always get that problem with this tool path. It never entry motion. Can I center on entry point? What does that change? Nothing. Yeah, I mean, that works. Not perfect, but it works. And you should make sure it's climb milling too. Yeah, that works. It's not the best, but it works. Okay, and that's 0.125 deep. You can see it, helix is nice, and then once it's done, it retracts out. I wonder if I added a little lead in, lead out. Like, we don't need a lead in. No, you can't even have one for this. Okay, that's fine. Because there's no finish. I see. Sounds good. Then we'll go to the next one, which is the circle. So we're going to do circle milling in this case. And I'm just going to select my circle, hit OK. The tool, oh wait, before I do that, let's watch that play out. Look at this. Look at the corners. They're not fully cut. Why? Because our tool is too big. It can't fit in that corner because the radius is too small. The tool's too big. That's why we're maxed out at a certain diameter that we can use. So you're going to switch it to a, you're going to get a new tool, and you're going to select a 0.375 in this case. 3/8 end mill. And you guys can do all your speeds and feeds. I don't have to do that with you all the time. I'm going to try to get out of here before security kicks me out. I got to go back to my shop. I'm in the retest area right now. They don't like when I'm here past 9, so. Okay, next, circle mill. Circle milling, I really like to see 1/2 inch end mills because anytime you're not limited to the tool, just use a 1/2 inch end mill because they just are really good. You got a certain length with it. So tool, we're going to go back to our 1/2 inch end mill again, speeds and feeds. In this case, though, let's do it. Let's pretend that this is 12. I'm just going to make up numbers. 12,100 inches per minute. But now when we're helixing in, we're actually cutting metal, right? When we're helixing in, we're coming down to our Z value. It's cutting metal. When it's plunging, it's cutting. So our plunge rate is going to be half of our feed rate in this case. Rapid retract, cut parameters. No stock on the walls or floors. Roughing, step over, 33%. Right? Finishing. No, we don't need finishing. Depth cuts. Yeah, we'll need depth cuts. We'll do 1/2 inch, right? Full diameters. We don't need any finishing cuts though, so just put that to 0. Breakthrough. It is breaking through the bottom of the part, so we're going to go 0, 10th breakthrough, and then we're going to go to our linking parameters and 1 inch, 0.1, 0.1. Our top of our stock is not 0 because we just cut a pocket. This square pocket goes down 0.125 inches. So where we start cutting is at negative 0.125. And our depth is all the way to negative 1.75. As you can see, the ramp doesn't start up here where it did for this operation, right? It starts up here because the stock starts here. Whereas in this one, the stock starts here, so it ramps down a bit lower. And you see 1/2 inch pieces. So let's, again, watch this play out. Perfect, nice, really like it. Very good so far. Okay, and then we're gonna do our holes now. The holes take some time. So we're gonna drill 1, 2, 3, 4, hit OK. In this case, let's take a look at our holes. So actually, you know what? Let's bring in a 1/4" spot drill first. We know that we're going to use a spot drill or a center drill, but I like 1/4" spot drills. They're nice. You can use a 3/8 spot drill. Again, do your feed rate and spindle speed. Cut parameters is just a regular drill or counter bore. Your linking parameters, again, is going to change to 1. Retract with 0.1. Top of stock is it's negative 0.125 again, right? Because that's where the material starts cutting. And the depth, right? If we want, again, I said for spot drilling, do a depth of, for spot drill, depth equals 0.05. But again, it can't just be 0.05, because if I say negative 0.05, that's just a little bit below our Z. We got to go the depth of the pocket where the hole starts plus 0.05, because it's all relative to Z0, right? So it's our top of our stock. So negative 0.125 plus 50 thou. So basically you take 50 thou, add it to the top of your stock, and it's going to be negative 0.175. Okay. So again, let's watch that and see that play out. Perfect. Bam. Okay. Now a new thing. We're going to do another drill. Okay. And we're going to hit just copy previous points. This little button right here. Hit OK. But now we don't know what drill to use. I'm not going to tell you. On the last test, I told you what the tap drill size was. I want you guys to be able to know, based off if it's a 5/16-18 tap, what drill size is it? Now you can look up online tap drill sizes. Okay. Images. You can search up tap drill chart, but the one I'm going to give you. Sorry, I'm going to look up tap drill chart, and I'm gonna print one off, and you'll get one on the test. It's going to be this one, and if our hole is a where's my thing? It's in. Why am I blanking right now? Sorry, Arjun just walked by. I saw it. Where's my test? Here it is. Our threads is a 5/16-18. So I'm going to go here, find 5/16 right here, 18. Again, the threads per inch, 5/16-18, right? And I'm cutting in aluminum. These are tap drills. Don't worry about the clearance holes. You don't look at this. We're cutting aluminum. We're always assuming that it's aluminum. So we go down and line it up with our 5/16-18, and that's a letter F drill or a 0.257. So in MasterCam, I'm going to filter for a drill, and I'm just going to filter it to a certain size, so equal to 0.257, and I'm going to go find my letter F drill. Perfect. Speed and feeds. You guys got that. This is going to be a peck drill because we're pecking through like 1.5 inches or 1 inch and 1.625 inches of material. That's a lot. You can't just drill it all at once. So peck drills, and our peck drill is going to be equal to our drill diameter. Our drill is a 0.228 drill, right? To make sure. I think it's a no, yeah. 2.257. So our depth of our peck is going to be 0.257. Again, I laid that out on this chart. Peck drill size is 100% of our tool diameter. Clearance 1 inch, retract 0.1, top of stock is negative 0.125, and our depth is negative 1.75. And we're going to add a tip comp because it's breaking through the part, so we want a tip comp and a breakthrough amount of 0.01. Hit OK. Bam, there we go. There's our hole going through. Again, well, we can watch that. Beautiful. Okay, then we're going to make another drill, and we're going to copy the previous points again, right? We're going to hit OK. And this time it's going to be a tap, and it's a 5/16-18 tap. So we're going to find a right-hand tap. I'm going to take this off, and I'm going to find my 5/16-18 tap right here. Okay. Now, again, this time we don't calculate our spindle speed because our spindle speed has to be 1,000 when we're tapping. I've told you guys this. And our feed rate gets automatically calculated, but you can do the calculation if you wanted, but it automatically gets calculated, so we shouldn't have to worry about that. This is a tap. I just want to make sure I'm still filming here. Yeah, okay, good. That would have sucked. Just tapping, and it knows what to do from there. Clearance 1 inch, 0.1. Top of stock is minus 0.125, and our depth is minus 1.75. And again, we're going to add a tip comp and a breakthrough. Yeah. Oh, wait. How deep are these holes, by the way? I never checked that. Do they go all the way through the part? I assume they did, but they don't. They go to a depth of 0.5 inches. My bad. I got to fix some stuff here. So let's go back to the PEC drill. And 0.5 inches is from the, 0.5 inches is from this face, not the top of the part, right? So I'm going to go to my linking parameters, and my top of my stock is negative 0.125. The depth of the hole that I want is minus 0.62, is minus 0.5. So if I want to go minus 0.5 and my stock, I'm already down 0.125, I go 0.5 plus 0.125, that gets me a value of negative 0.625, right? Now, I did say something on my chart that since we're tapping, our tap is going to go to the depth of negative 625 as well. So if the tap goes to the same depth, it's going to break. So we're going to add some extra depth to this hole. So then we're going to go to my sheet that I handed you guys, my programming general rules. Yeah, come on in. I'm just going to pause for a second because Arjun's coming in here. They're not in the class. Okay, so I'm just going to go away for 5 minutes. So just skip ahead 5 minutes in the recording until I start talking again. Okay, guys? I'll see you in a bit. Okay, guys, thanks for waiting. Sorry about that. He just he was doing his third year project, and he needed a supervisor to be able to work with the liquid nitrogen that he's using. Okay, going back here, yeah, we got to go to negative 0.625, but on our sheet we have here, it says when we're drilling, add 0.05 to the calculated depth of your tap, or to the depth of the tap, because the tap is going to make negative 0.625, so we're going to add another 50 thou to make sure that tap does not bottom out of the drilled hole. You would end up with a broken tap. So we're going to go to a depth of negative 0.675. Now you can still turn tip comp on, but we're not breaking through the bottom of the part. So your breakthrough amount should be 0, right? And that looks better, okay? Then I'm going to go to my tap, and my tap, again, no breakthrough because we're not breaking through, but my linking parameters this time, my depth is going to be minus 0.625, just 0.5 inches of threads like was called out for on the drawing, and then plus the 0.125 gets us 0.625, okay? Now, if I grab them all, you'll notice that my drill goes up to here, and my my drill goes up to here, and my tap goes up to here. So we get the ½ inch of threads, and again, that ½ inch of threads is from here to here, right? And then this extra thing is just us drilling a little bit further to make sure this tap does not crash into the bottom of the hole, okay? I'm really keen on that. I will mark you guys on that if it's not right. And again, if you don't understand, it's as simple as sending me an email and me sitting with you online, talking about it through, and maybe coming at it with a different way. Okay, so now we have it spot drill, drilled tap. Perfect. So let's watch that. Now the only thing, actually no, I don't even have to say that. Like, you can just do it. It's beautiful. You can see the drill goes a little further, right? Than the tap does. Tap goes up to here, the drill goes further. That allows the tap some room, right? And again, companies call for ½ inch threads. They don't care how deep the hole is normally. Sometimes it might matter. So sometimes companies will tell you how exactly deep to drill that drill, because again, it kind of takes out integrity, right, of the material. So there we go. That's most of the assignment. The last thing that we got to do is just do a chamfer. Okay, so our chamfer in this case is, let's do 2 chamfers. Let's do one. I know on this test, you guys only have to do one on the test, but my test is on the inside, but let's do one on the outside as well. It's calling for a 0.40 thou chamfer. So we're going to do a 40 thou chamfer. We'll do one on the inside of the circle and on the outside, just so you guys understand the difference. So let's do a contour, because again, we're just following a line. We're going to grab that line. We're going to make sure we're climb milling, as always, right? I might move the start of it. I want it right there just because I'm fussy. It doesn't matter. Don't worry about that. Tool. We can filter and get maybe a chamfer mill in here. We can use a spot drill. That works as well for chamfering. Anything that's 90 degrees. So you could use a spot drill, or you could use a chamfer mill as well, whichever one you like better, as long as that cutter is a 90-degree cutter. Like a drill has 118 degrees. You can't use, obviously drilling is only meant for drilling. But if you want to use, let's say, a center drill, that does not have a 90-degree tip, so you can't use that. Either a spot drill or your chamfer mill will work, okay? So, I don't know, let's just use a spot drill. Might as well. We already have a spot drill in the program, so where is it though? It's not here. That's okay. So use a spot drill. Again, speeds and feeds, you can figure that stuff out. No depth cuts, lead in, lead out. Yeah, anytime we're contouring, we want that little overlap. That way we don't get left at that mark. We're not breaking through, so we turn off breakthrough, right? Clearance 1, retract 1, feed plane 0.1, top of stock 0.25, and no, our top of our stock is 0, and our depth is going to be 0 as well, okay? And actually, I might be missing something here. Let's see it. No, that's not right. I don't think. Let's check it out. Oh wait, I am missing one thing. Sorry, that's exactly what it is. Our top of our stock is 0, our depth is 0, but then we go over to our cut parameters. Oh, and we change this, yes, to 2D chamfer, right? And then our chamfer width is 0.04. I thought I was missing something. I haven't done this for a long time. So we could leave the bottom offset on. That's fine. It doesn't matter. Just change the chamfer width to the width of the chamfer and hit OK. And that automatically updates the chamfer for us. Look at that. Like I said, in the drawing, I literally say top of stock equals the value of the top of the chamfer. The depth is the top of your stock. Okay, so meaning that they mean the same. In this case, our top of our stock is 0, so our top of our stock is 0 and our depth is 0. Okay, let's watch that. Beautiful. We get that little 40 thou chamfer. Maybe I'm making this look easy for you guys. I don't know. Let me know. If I'm confusing, let me know. Let's do another one, exactly the same, but this time it's going to be on the inside. Again, make sure it's climb milling. Then tool, we're going to select a corner spot drill again. Again, you could use a chamfer mill if you want. I don't care. As long as the chamfer, like the chamfer of the tool is bigger than the chamfer you need. Again, we're going to do a 40 thou chamfer. Everything's the same, lead in, lead out, yes. But in this case, our linking parameters, our top of our stock in this case is actually negative 0.125 because it's the top of the internal pocket. And like I said, our depth is going to equal our top of our stock. And bam. Warning, tool is too small to create the chamfer. What size of chamfer was I using? Because I just made a chamfer 0.04, so why is it not working now? 0.04. Bottom offset 0.1. Maybe we'll take that 0.0, make that 0.01. That should change that actually. That time it worked. There we go. Okay. Let's watch it. Ooh, I'm getting two different chamfer sizes here. I'm getting a smaller one and a bigger one. Something's off. Something's not right. 50 thou. 50 thou, 50 thou. Which one is wrong? That's the question. Let me think about this question. 40 thou bottom offset. When we change the bottom offset, it was 0.1, saying the tool is too small. Okay, let's make a bigger tool. How about that? Easy solution. Select a library tool. Let's use a 3/8 spot drill. Try it out. Still getting bigger on the inside and smaller on the outside. Parameters. Bottom offset 0.1. Bottom offset 0.1. I know. Maybe. No, we don't have any breakthrough on either. Huh. Parameters, top of our stock is minus 0.125. Let's go back to our pocketing. Our depth is minus 0.125. Interesting, interesting, interesting. Not getting what I want. Sorry guys, I haven't used MasterCAM for a little bit. Again, I normally use GibbsCam here, so sometimes I have these little brain farts when I'm relearning the software. 40 thou, 45 degrees. We change the top of our stock. This is so weird. What the heck, man? What are you doing here? Quarter and spot. And I don't get, why the 1/4 inch spot drill, maybe this is my clue to figuring this out. Why is it saying that the 1/4 inch spot drill is too small for what I want to do? I understand that. I do understand what it means by that, but why? Why is that? Negative 0.125 and depth is minus 0.125. Cut parameters, 40 thou, bottom offset of 0.1, just like before. And overlap 0.01. No, that would not do nothing. It would just be if there's a breakthrough. That would be the only thing that can mess that up, other than our linking parameters. Our feed plane top stock is negative 0.125, and our depth is minus 0.125. Chamfer width of 40 thou. What the heck? 40 thou. 40 thou. Computer left tip. There's something that's missing in one of these, and I just can't think of even what it could be. I honestly can't. We're using the same tool, 1/4 inch spot drill, right? 1/4 inch spot drill, 1/4 inch spot drill. What could be different? What could possibly be different? Other than the depth that we're working at. Wait a second. Okay, I got it. And that's because I kept it as a 1/4 inch spot drill, even though it said it wasn't big enough. Why did I get that alarm then? I don't understand why I got that alarm. I don't know what I did. Okay, there we go. It worked out. That's exactly what I'm supposed to have. And even though, like, why would it change if I change my tool? That shouldn't matter either. I'm just curious, guys, now. You saw how I did it. I did it the way I told you guys to do it. I'm just curious to why that is. 3/8 flat I meant. Okay, obviously I can't do that. 3/8 spot drill I meant. Now it's bigger. Okay, let's try this. I want to see which one's wrong. I'm going to make the diameter. This is a 1.5 inch diameter hole. I'm going to make a diameter of 1.5 plus 0.04 plus 0.04. That way we know exactly what that diameter should look like. I think I figured it out though. Diameter 1.58, enter, and center point. Okay, so our chamfer should go up to there. So let's watch it now. So actually, this chamfer it's a little bit smaller, but it's almost there. Let's change it to 3. I'm actually curious now. Let's go back. So this one, let's go to a 3/8 spot drill. Hit OK, and let's watch it. And play. Okay, that's why I'm stupid. Okay, so this you could see is making a perfect chamfer. And that's because I bet you if I went back and I changed this tool and I went back to a 1/4 inch spot drill, here, let's go to a 3/8 spot drill, and let's go back to a 1/4 inch spot drill. I get that alarm saying that the tool is too small to create that chamfer. I'm stupid. I ignored it the first time. I didn't see it. So it's saying that the tool is too small to make that chamfer, so it just can't make as big of a chamfer as I wanted. So what I would have had to do is just simply find the next biggest tool, 3/8, and then there we go. So if you get that alarm, you just got to make the tool bigger. I was stupid. I didn't see the alarm on the first one. That's why. There we go. There's our 0.04 chamfer. Bam. Bam, wham. Thank you, Sam. That's it. That is all. That's the test. And that took, I guess, us like what? Half an hour, 45 minutes? Probably close to half an hour without the big break in there. Forget. No. Yeah. It was at Argent for 15. Yeah. So again, that's your test. You'll do one chamfer, 4 holes, spot drill, drill, tap. They could be at varying depths, right? So make sure that's always relative to the Z. Facing, circle milling, pocketing, contour on the outside, and a chamfer. And that is the test. And your test will look exactly the same. If you see in my, I don't even have it, but you'll notice that, again, all the tests are the same. 4 holes, 1 circle, 1 square, 1 outside profile, right? So it's up to you guys. Study, try it over and over and over. Try Ted's part, try my parts over and over and over, right? I'll post this right now before I forget, and I'll post that cheat sheet, and I'll print off the cheat sheet and the tab drill chart for you to take on the test. You guys don't have to bring anything except a calculator and your brain. Okay, guys, that's it for me. Hopefully this helps you study for the test. Again, you don't understand something, now's your time to reach out. Have fun, guys. Good luck. See you tomorrow at tomorrow's test. We're almost there. Okay? Peace out.